Hello everyone, a very warm welcome to you. Today we are going to look at strings in that, right? We have discussed the various data types that we have in that programming language, and we just had an overview of those different data types, right? So that was just an overview, but now we are going to be um, going into them one by one, right? We are going to be looking at their properties and ways we can manipulate the different data types that we have in that programming language. So we're going to start with the first one, string, right? And if you remember clearly, I taught you guys that string simply refers to a collection of characters, right? So anywhere you have a collection of characters enclosed in quotes, right? Be it single quotes or double quotes or even triple quotes, you have a string, right? It's just a collection of characters enclosed in quotes. All right. So right now we are going to be looking at the properties of strings. Yeah. So as you can see, it says here now. This website is tutorialspoints.com. All right, and this is a website where you can go and learn different programming languages. You can learn JavaScript, you can learn Python, you can learn that on this same website. All right. So right now, because um, we are taking a Dart course, right? I am referring to this website for the purpose of this tutorial. Okay. So it says a string data type represents a sequence of characters, which is what I said. All right. A Dart string is a sequence of UTF-16 code units. We are going to look into this maybe later. All right. Not now. So the string values in Dart can be represented using either single or double or triple quotes. Single line strings are represented using single or double quotes. Triple quotes are used to represent multi-line strings. All right, and then below is the syntax. So you can see the different declarations. You can see the different string declarations. All right. So this particular string, the value of this um, string is wrapped in single quotes. This is wrapped in double quotes. This is wrapped in triple quotes. All right, and you can even have um, this. All right, you have um, how many now? 6. So all these are strings. All right. So um, let's look at the properties. I don't know if we did string interpolation. All right, but if we didn't, if you haven't done it already, um, I will refer to it in the next lesson. So let's look at string properties. We have code units. Okay, code units. So what does code unit refers to, or what is code units? Code unit returns an unmodifiable list of UTF-16 code units of the string. Okay, so let's have an example. I'll name my file strings.dat. Okay, dat files. Yeah, all right. So let's say I have uh, this string greet, and it is initialized with hello world. Right. already we have a string, right? And of course, I must have my main function. If I'm going to execute anything in this file, in this dot file, I must have my main function. This is what helps me to execute my code. All right. So code units. Let's look at this. Okay, as I earlier said, it returns a list of UCF16 code units of a given string. So each string, every character in um, in computer science, in computer programming, right? Every single character has a code, right? It has a code, and this code is known as ASCII code, right? So ASCII, if you I just googled ASCII code now, and it's defining ASCII. ASCII is a character encoding standard that assigns a unique numerical value to numbers, strings, and symbols, so computers can process them. All right. So this is um, a character encoding system that the computer uses to process strings, to process data. Okay. Yeah. So we have what we call the ASCII table. So if I visualize this ASCII table, you can see that every single character has a code. Okay. Look at this properly. All right. So these are the symbols. All right. And these are their codes in decimal, in hex, in oct. All right. And then in binary format. But since we are more familiar with decimal codes, that's normal numbers from 0 to infinity, all right? 0, 1, 2, 3, 4, 5, 6, 7, 8. We are more familiar with decimal numbers. We are going to be looking at this column, this um, DEC column, all right? This DEC refers to decimal. So these are decimal values. These 0, 1, 2, 3, 4, 5, and so on are decimals, all right? And the decimals they simply refer to our normal counting numbers, the numbers that we use every day for counting. All right. So we have these various symbols. Okay, and these are the ASCII codes. Right. These are the ASCII codes. If you convert these um, numbers to binary, this is what you have. This BIN represents binary. All right. And in case you don't know, um, the computer actually visualizes data, or rather, the computer works with binary codes, right? Binary numbers. So every single character on our keyboard, right, is being translated. When we use them on the computer, it is being translated to binary code because the computer does not understand. Um, the computer does not understand English, right? It does not understand English language. So, for example, I have this string for instance, or let me just use my name. I have my name. Okay. Now, if I just print my name, right, this is what I'm going to get, this data, right? And um, the computer does not see my name as EBUKA, right? So a process. There's a process to this thing, right? We have our human readable language, okay, which is actually compiled down to machine code or binary code, Let me call it machine language. All right. So whatever I write here in my dat file, all right, to be executed by the computer is actually going to be compiled down by, is going to be broken down by the interpreter. All right, it's going to be interpreted to the computer in the language that the computer understands, which is machine language or binary code. All right, so this binary code simply refers to ones and zeros. All right, so the computer understands ones and zeros. Okay, and that's why at the end of the day, all of these digits is going to be interpreted to the computer. It's going to be converted to binary code and interpreted to the computer. All right, so this is actually some low level stuff. All right, but I did that to, I explained this to help you understand why this particular property code units is important. Right, so let's look at my string now. For instance, if I do name, right, my name dot code units, I'm going to have the code units of A, of E, of B, of U, of K, and of A printed here. All right, and mind you, the code unit of capital letter E is different from the code unit of small letter a. All right, uppercase letters have different code units from lowercase letters. If I were to say, let me call this name 1 E. Okay, so let me print them side by side. Name 1 dot code units. You see that I'm going to have something different for lowercase e. Okay, if I say EBUKA all in uppercase, yeah, you can see that what I have here is going to be totally different from what I have here. All right, so this is informative in the sense that we can know that, like, it tells us that this is what is going um, to be interpreted to the computer in binary form, in binary code. All right, so if you want to know how the computer sees these two strings, just convert these numbers to binary code. That's base 2. All right, convert 69, 66, all these numbers to base 2, and you're going to have the interpreted format of this data. All right, so that's what code units does. Now let's look at the next property. Is empty. It returns true if a string is empty. All right, so let's say I've looked at code units. All right, so let's look at this is empty. I'm going to print name dot is empty. What does it mean? It checks if this string is empty. All right, this name string if is empty, and of course it has 5 characters in it, so it is not empty. All right, so if I click run, I'm going to have false because this is not empty. And we actually have another property called is not empty. All right, now this time around I'm going to get true because name is actually not empty. Okay, now let's say I have an empty string here. I'm going to remove everything, so I just have an empty string. There's nothing inside. If I run name dot is empty, right, I'm going to have true because name is actually empty. Okay, and another property we have is the length property. So let me just do a quick check. Name dot length, okay, 0 because there's nothing inside here. But if I do name 1 dot length, I'm going to have 5, right, because there are 5 characters in here. So that's it for the properties. Okay, so let's look at the methods and description that are used in functions, in strings. All right, so with this we can manipulate strings, and I'm going to show you how. Okay, So the first one is to lowercase. What does it do? Now let me bring this back. What to lowercase does is very simple. It converts every uppercase character, every uppercase letter to lowercase. All right. So now I have this, all of this, EBUKA. If I want to convert it to lowercase, I'll just do dots to lowercase and run, and everything is converted to lowercase. All right. And also we have to uppercase. Now I'm doing name one, which is this lowercase letters, this collection of lowercase letters, dot to uppercase. If I run it, I have all of them now converted to uppercase. All right. So that's what it simply does. And I have dot stream. What dot stream means, what it does is that it trims down my string. All right. It trims it down by removing any any excess space before it or after it. I don't know if you understand. Let's say I have a space here, or even at the beginning, I have a space. All right. Now you know that this is not um, the data I intend to have. This is not the string data I intend to have. All right. I just wanted EBUKA. But let's say somehow by some mistake, I have these extra spaces. All right. And of course, if I do dot length, I'm going to have, instead of 5, I'm going to have 7. All right, because these spaces are actually also being counted. Okay, so what I can simply do is I'll just stream dot stream. What the stream does is it removes the extra spaces before or after it. All right, and if I run, you may not know whether these spaces are still there or not, but I can be sure by doing dot length again. All right, so after trimming it, I'm checking the length. All right, so if I run it now, I will have 5. Okay, so we actually also have this compared to. Now let's read and see what it does. Okay, this returns a new string by removing, no, this is talking about string. Okay, yeah, so this returns an integer representing the relationship between two strings. It's going to return 0 when the strings are equal. That's when you compare two strings. All right, so this compare to is actually used to compare two strings. It's used to compare one string to the other. Okay, we looked at code units earlier, and as you can see, some numbers, some. Let me go to where the alphabets begin. Yeah, so we have letters here, letters A to Z. Okay, and they all have their respective code units, which is from 65 to 90. All right, so this actually means that some letters are bigger than the others, some letters are greater than the others. Okay, so let me have um, something very simple. String letters. I'm first going to have A, and then, okay, I'll call this letter 1, and this will be called letter 2. All right, so I'm going to compare these two to know which one is greater. All right, so if I come here, in fact, instead of doing everything inside the print statement, I'm just going to create a variable. It's going to be a boolean because compared to dot compared to actually returns no, it's going to be an integer because it returns an integer. All right, dot compared to returns an integer. So I'm going to create an integer here, and I'll call it compare, and then I'll perform the operation here. Letter 1 dot compare to letter 2. Okay, now print compare. So what this simply does, um it compares letter one and letter two and returns and stores um the results of this operation in this variable, right? So comparing letter one and letter two, of course, letter two is greater than letter one, right? So if I click on run, okay, I'm going to get minus one. Why? Because it said when the first string is smaller than the second, you have minus one, right? But it also says here that when the strings are equal, zero will be returned. And when this first string is greater than the second, one will be returned. So let me compare letter two and letter one. Comparing them, I'm going to have one, right? But let me compare letter one with itself, for instance. I'm going to have zero, okay? And let me look at this ASCII table again. Okay, so I came here to find something that is actually lesser than A, which is this at, all right? So I'm going to um, store, create a variable called car. So this is going to store this particular character, okay? So if I say car dot compared to letter one, I should have minus one here, okay? Because in the ASCII table, A is greater than at, right? So that's 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 what compared to does. Simply compares two strings, all right, and returns an integer based on these conditions, okay, based on these three conditions. So let's move on. Replace all. So replace all replaces all substrings that match the specified pattern with a given value. All right. Okay. I think we have done quite enough in this lesson. So let me stop here. All right. And I want you to go over this lesson as many times as it takes you to understand these concepts. All right. And we'll see in the next lesson. Thank you.